Hello, welcome back to Sokobond Express. We finished our first 3 worlds last episode, which introduced us to a very interesting new concept in the game. So let's keep going. Going to go to the Delta section now, which has 6 levels instead of 5 as each previous world had. But let's do this. Alright, so supposedly we're learning a new mechanic now. This looks pretty normal though. It's just that. So why is this any different? Is this just a precursor level? No, it's a level that teaches us that at your end state, levels cannot go over the ledge. Which probably means I have to do something like this on the side. Okay. Interesting. Yeah, okay. Keep all molecules in the play area. Despite not knowing why it worked, ancient civilizations noticed that disinfectant power of copper and uses it to sterilize wounds and treat drinking water. Why does that work? Alright, so now we know. Our end goal is this. Okay, so it means that in our methane compound, we have to be on the left side. And we can't drag to any hydrogen. So the logical deduction here is being on the left side, this is our first move. And must be our first move. Now going down here traps us, so we have to go this way. Doing this also traps us. It doesn't trap us, but it traps this hydrogen, which we can't touch anymore. So we must do that. And now we just need one that goes on the left and one that goes on the right. That doesn't work. So this would work. Sure. Very fun. Scientists are genetically modifying cotton to try and produce colored fibers without need for dye. Meaning no need to separate laundry. Ah, yeah, okay, yeah. Because colored when your shirts get colored by other shirts, the dye coming off. But naturally colored fibers is interesting. Sure. Level 3. So 2 branching off of sections here. Okay, what is this? This probably has to do with the connectivity again. Is this like a hydrogen? Is this just a H2O chain? H2O3. It could be just a H2O3 chain, like something that just looks like this. But this clearly wouldn't work because a lot of stuff is out of the play area. But this is potentially a molecule that it can exist. It doesn't because it's really unstable as a molecule. So if I am standing here in this final state, I probably want to put hydrogen here. And then maybe make like a zigzaggy pattern. Yeah, seems like a great idea. That works. That wasn't really zigzaggy, but okay. Sunscreens can be physical or chemical. Chemical sunscreen absorbs UV radiation, turning into heat that can be released from the skin. Really? Okay, that is known as... Well, I'm not sure if this is an exothermic, right? Because it doesn't really... Well, it does like release heat. Maybe it is an exothermic reaction. Epsilon, yeah, that comes after delta. So what would the next one be? I forget what comes after epsilon. Oh well. Alright, so similar concept here, except we're going to be ending in this spot. So nothing can bond to our right. So a straight line like this wouldn't work. Okay. Or maybe something like this would be fine. Not too much of a problem. Maybe this. Yeah, this works, doesn't it? It forms a U shape around this bend. Nice. When the solution fits like right in the puzzle play area, that is very satisfying. Did you know? You know the distinctive just rain smell? It's called petrichor, and it's caused when the molecule of geosmin is pushed out of the soil and into the air by raindrops. So like that's actually the smell of soil, you're saying? Interesting. We're at level 5. Actually, I don't see any connection between these two. Like, you can see there's a connection or a bond between this and the next section, but not here, so I wonder what that might mean. Okay, anyway. These guys just being off the play area. Well, not off, but there. What kind of molecule is this? This is a huge one. Is it nitrogen? It could be nitrogen with two H's, bonding to O, bonding to O, bonding to an H. Okay. I do know that going down doesn't work, because once you go down, you can't really get in to get the O and come back out. So the first step has to be getting the O like this. And if we were to follow the process that the molecule that we believe to be true before, then it might be a mistake though. That's not true, is it? This can happen. Yeah, so this can't happen, and I deduced that because if we were to do this, then how are you going to go in to get the H and come back out? We can't. So actually, we have to get the nitrogen first. And this nitrogen will bond to one H and one O. The question is, how will it bond to this though? How will it bond to this H over here? Is this already a flawed... No, doing this just fails. This is forced. Yeah, but I can't get this... Well, I can get N like this, but the product is the same, so... isn't there no difference? If there was no difference, then... Well, I can get the H like that, so maybe that's what the H that this one gets, and then the oxygen can get this H instead. Yeah, okay, that feels more right. Sure. Okay, that feels a lot more like... something. It feels a lot more like... I don't know. The taste of coriander is influenced by our genetics. If you have a receptor gene that lets you detect chemicals called aldehydes, eating coriander is like chewing a bar of soap. Oh, you know what? Okay, I see. This could be true for like a lot of other vegetables, right? Maybe. Because like some people really don't like the taste of certain vegetables. And like other people don't understand why. It might be because of this. Oh, that's really interesting. I think that's really interesting is that it's genetically based though. I'm not sure if like maybe people in the same family have the same... Not sure. Let's keep going, it's fine. Zeta. Alright, we'll go to Zeta next. There's no direct bond here, so I'm not entirely sure what's going on there. But okay. Anyway, final level of this section. What are we making? This looks like it might be another loop, honestly. Yeah, it has to be another loop, I think. So oxygen can't bond directly to another oxygen. We don't have ions here. So a double bond will immediately be formed, which forms a full molecule already. We have to bond to a nitrogen first. So I can either do this and go around. That actually immediately breaks. Because doing this immediately forms a molecule that's already full. So I can't do that first. I have to connect to here first. And I guess then the nitrogen has to grab the oxygen. Would this work? I mean, this looks like it will work. No, but it'll be too high. So going back to the same idea, this can't happen. Okay. Well, the oxygen can bond to another oxygen. It's just that it will also be too high. So probably not. Okay. Well, I'm almost certain that this has to happen though. Unless I can somehow dodge that. Maybe I can, maybe I'm supposed to. Is this fine? This might actually be fine. No, this actually forms our full molecule already. So no. But doing this doesn't really work either, because either we do this, or we somehow go around the oxygen. Okay, we can't bond to oxygen directly. Doing this almost blocks the entire path for us. That doesn't do anything different. Maybe I have to do this somehow. There is a problem here though, but maybe that's resolvable. Not entirely true. This must be here, so nothing can be on our left either, our right either. Nothing can be like 2 cells above us. So like this would be fine though. Not true though. Maybe there's something like this. Yeah, this actually almost immediately breaks. So what's going on here? This is not like forced. Maybe not. I can always do this. Maybe this is fine. Yeah, this actually looks fine. Can go up here. Oh, what an interesting path. Sure. And there is actually no loop being formed here, so I was mistaken. If we're sleepy, we often reach for the coffee. That's because it contains caffeine, which binds to nerve cells in the brain, leaving no room for sleep-inducing chemicals. It's an inhibitor. Wow. Yeah, that's new. I didn't know. Caffeine is an inhibitor of some sort. There are a lot of things that are also inhibitors. Basically, when you feel the need to pee, that's an inhibitor for your brain telling you need to pee. That's one example of an inhibitor as well. Another interesting fact is that Coke contains caffeine, but I'm pretty sure everyone knows that already. Alright, let's move on to the next world. Epsilon is the next one in the list. We can also go to Zeta, which comes from level 5. But let's go to this one first, because it seems like more the normal progression. Is Zeta after Epsilon? I think it might be. What is this? This is a bridge. Okay. We had those in the Cosmic Express. Okay. So typical ammonia arrangement here. Can go do this, do this. Going up here actually would actually form a bond like that, so can do this, but no, this breaks. It has to be one on our left and one on our right. Understandable. Deja vu, travel the same tile twice. Capsaicin in spicy peppers makes humans sweat, but birds are unflappable. Okay, that's a pun. I didn't even know unflappable was a word. Bird digestive tracts simply don't register the chemical and thus don't get that burning sensation. I wonder if this is like a result of evolution, because birds eat from trees so much that while peppers evolved to contain this chemical to deter us, could birds somehow have evolved further than that to then develop the inability to register capsaicin? Because it doesn't make sense for peppers to just randomly develop something that is coincidentally spicy for us but not for birds, right? So I'm not almost certain, but my guess is that capsaicin was first evolved in peppers to deter birds, but then birds like counter-evolved. That's insane. That would be a really insane thing to happen. Alright, we have another branch going off here, which actually is earlier in than the supposed branch. And this question mark didn't come out. So we would have to actually... Wait, was this question mark here? I don't know. Okay, N, C, N, and O. Any branches here? I don't think so. N can form a direct triple bond with N, but we don't want that. So possibly what I want to do is actually co-bond with O first, and then with C, and then C will bond with N. Yeah, that seems like it. Okay, that was a guess, but we were lucky enough for that to work out. Also, is it just me? Those lines there, I don't think those were intentional, but it's okay. Triple bond, this is our first triple bond as well, I think. Olympic gold medals are actually made from silver and then coated with at least 6 grams of gold. Going for gold-plated silver doesn't sound exciting as going for gold though. Gold-plated silver. Yeah, gold plating is really interesting. I've seen a lot of golden things in my life, but none of them actually have gold in them. I wonder how gold paint is made. I wonder how fake gold color is made either. Is it just really shiny yellow colored objects? Maybe. Like, copper somewhat has a shine that is similar to gold but isn't actually gold. So maybe there exists some sort of yellow metal that shines really well, that looks like gold. Maybe some alloy of some sort, because I'm pretty sure there's no like Ada. I'm pretty sure there's no like element in the periodic table that has the same golden shine as it, which maybe makes it that unique. Not sure. Alright, let's continue. This is hydrogen peroxide. I can see why this exists, because going for this oxygen kind of prevents us from going to this hydrogen and back, and we can't go for this hydrogen directly. So we need to somehow use this to... oh, well, we need to make a double trip almost. Yeah, so we need to go to oxygen, come back, and then go for... we need to go to oxygen, come back, and then go to the end again. Which is like 2 double trips we need. That might not be true. That might not be true. But I'm really scared of accidentally blocking myself off the exit. Like something like this would block off the exit. And I'm almost certain if you want to grab that oxygen, you have to touch one of the edges, which would naturally block you off. And not touching it is also not an option. If I did something like this, I can form hydrogen immediately, but that breaks off and we can't actually form any H2O2 from there anymore. So to make H2O2, we must touch both of these oxygens. Maybe I can use an extension, right? Maybe I can use one of these oxygen extensions to not touch the edge. Maybe. But if I were to do that, I would at the very least touch this corner, and that is equivalent to being blocked off because these two guys count as walls. So yeah, no, that doesn't work either. If I tried to go directly here, then going back, it doesn't allow me to go back again, so I don't know what that would mean. Maybe going from the side is fine? Maybe going from the side is fine. The problem is that... okay, the problem is that this is plausible, but requires a pretty specific extra setup for it to work. To actually reach H at this point, I will need something on my left like this, so I can bond like that. And therefore my shape has to almost sort of be H here, O here, and O here. How do I get an O to be on my right side though? Like this O. I don't think I can get to be on my right side. So almost, it might be something else. Is there anything else I can do besides this that works? Like, I'm pretty sure this doesn't work somehow. Like, this just doesn't work at all. This blocks everything off. But this would work. Just really hard to figure out what to do from here. Oh, but you know what? Something that could happen is actually forming the bond while I'm going down. Like, this actually works. So what should be the case is actually forming a bond like this. This allows you to reach you while on the bridge. Also, I can't make a stop on the bridge. Why? It just bounces back. Maybe there's some bug that... maybe there's some bug that allows some really weird stuff to happen here. So you must go a straight line through the bridge. Yeah, there's also been no ability for us to bend across a bridge yet. Okay. Cool. This is a cool logic puzzle to figure out exactly what you need to get through this. The enamel that coats our teeth is the hardest substance in the human body, but is vulnerable to attack from squishy things like fruit juices and candies. Oh, like, okay, like metaphorical. I thought you meant physical damage. But you mean the breaking down of enamel from sugar. Is it sugar or is it bacteria? I think bacteria... I actually don't know what breaks down enamel. Because it's both, it's likely for either of them to actually break down enamel. Because I don't know what enamel actually is. Could be either. Interesting. Alright, we have theta. I guess we're going in order. After this we have to go to delta, zeta. After zeta we'll go to eta, and after eta we go to theta. All three of these eta people. Eta groups. Alright, what is this? HHOC. O here, bonds with O there. Not enough space. I feel like it has to be... it has to be a double bond with C. Like, C has to form a double bond with O. Otherwise, we just don't have enough bonds to work things out. Yeah, okay, so I see how. C forms a double bond with O. It forms a single bond with OH, and it forms another single bond with H, which gives you 4 bonds on C in total. That is something known as an alcohol, or methanol in this case. Yeah. No, it's not. It's a carboxylic acid. Oh gosh, I've forgotten all my chemistry. No, COOH is a carboxylic acid. In particular, this one is methanoic acid. Methanol is just a regular OH. And OH with a double bonded O is not the same. But that tells us that C has to bond with O directly, which means we can't touch them until... Yeah, we have to touch C first, and then touch O after that. Which is probably why this bridge exists. It might have something to do with like this, and then leaving. That seems plausible. And then actually after this, I can probably go... Oh, I can't. I can't form a bond with that. Okay. How about this? Will this let me form a bond with H like that? It will. Wow. That's a convoluted path. But this full space was required, which is quite satisfying. Cool. Water boils at 100 degrees Celsius, right? Not always. Water's boiling point rises as high air temperature gets higher. Pressure cookers use these high cooking temperatures to cook your food faster. Hence their name. Yeah, there's this huge, massive graph that tells you about boiling point in lines of changes of states of matter. Basically, when you have water, right, at different temperatures and pressures, the state is different. So we have this graph. I forgot what it's called, but the graph basically is a map-like region indicator where wherever you are in terms of pressure on one axis and temperature on the other axis can tell you exactly what state a chemical will be in: water, liquid, or gas. And probably plasma eventually, but that's a bit high for like basically any chemical. So we don't normally talk about that on those region, temperature, atmosphere, pressure graphs. Alright, this is this more than before? I feel like we've seen a molecule that looks like this before. If C forms a double bond with N, the N can form a single bond. It can form a triple bond with N actually. In fact, we might have done this before. So C can form a triple bond with N, not in this case. So like this is how triple bond can form. Not exactly what we want though. If you want a triple bond to form, the C forms a single bond. The C can form a single bond with oxygen, which forms a single bond with nitrogen, which forms double with oxygen here. Something like this. Yeah, that double bond can work. It's just that this is not a very good position. So maybe on the top? No, this doesn't work. Maybe on the other side. No. This is somehow not enough bonds, right? We need to go form a direct bond with oxygen. With carbon, I mean. But I can't form a bond with carbon yet because the carbon-oxygen bond is a single bond. Which means that I do have to bond with nitrogen first. I can do it in a few ways. I can do this. This actually might be better for us. No, this actually doesn't work. Maybe this? No. This might work, but it doesn't give us enough space. Maybe this is fine. We have to use the bridge somehow. I'm thinking I have to do something like this. Maybe this is fine actually. No. No, this is not fine. Maybe there's a loop then. Not really. I can't really tell how this would work. Because it again doesn't let me go back. Maybe this is fine. No, well, this might be fine, but I can't actually get back either. I can't bond carbon in this case. Okay. Maybe the first step is not to bond this nitrogen, it's to bond this nitrogen instead. The problem is that once I do this, I can't really escape without bonding nitrogen, and then the entire thing is just foiled. Maybe this nitrogen can bond with carbon. Maybe something good happens here. No, this forms a single bond, which doesn't work well. I just want to see if there's something works here, but I don't really see how anything might work. What is this bridge for? I could do that, but clearly doesn't seem to actually do anything for me. If nitrogen bonds with nitrogen, does it allow another... Oh, it does allow a double bond to work, so that's a valid thing that can happen. Okay, maybe that's what this bridge is for. I'm gonna go around and get back here. So maybe something like this? No. I thought I needed nitrogen to be like... not there. Below? Oh, there it is. Nice, there you go. Cool. That's a very odd compound. Animals that glow in the dark, like fireflies and some deep sea fish, use a chemical reaction in their bodies to produce light. This process is called bioluminescence, which is why you see those like beautiful blue glows on beaches sometimes. On the internet, I don't actually see them in real life, unfortunately. Okay. Let's keep moving.